Hi, my name is Amin Muramai and thanks for joining this audio slide presentation of my paper, A New Model in Infrastructure Layer for Increasing the Security of Virtual Network in Cloud Computing. It is obvious that the next evolution step of on-demand IT services is cloud computing. The responsibilities of security in three layers of cloud computing are different, so that in the software layer, service provider is responsible for physical security and has the task of implementing foreign policy of firewall. Security of platform layer involves both of the user and the service provider. At the infrastructure layer, the greatest burden is on the users. The purpose of this paper is to introduce a new structure for dealing with a variety of attacks on the virtual network, because one of the key issues in virtualization is isolation. Isolation plays a crucial role in VMs in order to guarantee that one VM cannot affect the other VMs running in the same host. Virtual network is a method of creating independent or isolated logical network within a shared physical network. In this paper, we use Xen Hypervisor to demonstrate how the virtual network works. Xen hosts multiple guest operating systems, each of which is executed within a secure virtual machine, or in Xen terminology, a domain. The first domain, domain 0, is created automatically when the system boots and has special management privileges. Xen offers two modes for users to configure virtual network: bridge and route. In the bridge mode, instructs Xen to attach the VM's interface directly to a software Ethernet bridge connected to the physical network. The administrator can handle VM network DHCP requests the same way as handling common network DHCP requests. The second mode offered by Xen for the configuration of virtual network is route. This configuration allows the administrator to create a point-to-point link between domain 0 and each VM. A set of MAC and IP addresses must be defined in advance, because routes to each VM should be added to domain 0's routing table before a VM is started. So in this mode, each VM instance created by Xen is assigned a free MAC IP tuple and released when the VM is terminated. DHCP doesn't work in the route mode. As we discussed the virtual network configuration modes in Xen, it uses the virtual network to link VMs by using bridge and route. In these modes, the performance of inter-VM communication is near native when VMs are running on the same host. As a result, isolation is easy to be broken. These two vulnerabilities existing in the current virtual network: sniffing and spoofing. In the bridge mode, bridge plays a role as a virtual hub. All VMs share the virtual hub to communicate network, in which a VM is able to sniff the virtual network by using sniff tools such as Wireshark. In the route mode, route plays a role as a virtual switch. The virtual switch uses a dedicated virtual interface to connect each VM. In this case, a VM can do an address resolution protocol spoofing, redirecting packets to them and be able to sniff packets going to and coming from other VMs. According to the vulnerabilities existed in the virtual network above, we leveraged the characteristics of route and bridge modes and combine them to propose a novel virtual network model to make the communication among VMs more secure. This model is composed of 4 layers: routing layer, firewall layer, IPS and IDS layer, and shared network layer, as shown in figure. Routing layer. This layer has the same functions with the traditional route mode. It is this layer's responsibility to connect the physical network and create a logical dedicated channel for the communication between the virtual network and the physical network. Firewall layer. The main purpose of this layer is to prevent spoofing attacks. In this layer, we define a set of security policies, mainly including 1. Each virtual interface in the routing layer that connects with a virtual shared network cannot communicate with any other virtual shared network. 2. Any packet that tries to modify the routing table will be dropped. Intrusion detection and intrusion prevention, IPS and IDS layer. These tools are responsible for a more in-depth analysis and provide a higher level of protection. These tools analyze the traffic and each information packet compared with a database of known attack profiles. When attacks are detected, the tool will take an action. IDS tool notifies the occurrence of an attack, but IPS tools go a step further and automatically block malicious traffic. Here, as it is possible, lots of known and unknown attacks cross the firewall, with network behavior analysis provided by these tools can be more secure. And finally, shared network layer. In this layer, we assume that VMs belong to the same virtual shared network are trustful to each other. This assumption means VMs working for the same company or organizations should be allocated in the same shared network. Thanks for your attention.